I'm Tim. This PCB Sync.
A lot of engineers, when they first start working with RF, see others using Rogers boards and want to use Rogers themselves. It feels like if you don't use Rogers, your project isn't professional enough. But in reality, many RF products have never used it in their entire lifetime, and they've still sold millions of units. So today, we're going to tackle one question: when do you actually need to use it? So let's take a look. What's the biggest issue with Rogers? Well, it's not performance, it's mainly the price. It's just way too expensive. A lot of times you only get a 10% boost in performance, but the price might go up threefold. When the boss sees the quote, their blood pressure shoots up right away. What really determines the choice of material usually isn't sentiment, it's the frequency. We can look at this chart. If it's below level 1, then FR4 or other common products will do just fine, like our 433 megahertz remote controls or the 868 or 915 megahertz ones. For GPS, the frequency is between 1G and 3G, and FR4 is still very commonly used. Some common products here are Wi-Fi, Bluetooth, and so on. When the frequency goes up further to between 3G and 6G, then you really have to start considering your options. Should you use F24 or Rogers? At this point, the common products are actually 5G and 5.8G Wi-Fi communications, and even some drone communication systems. If the frequency keeps increasing, when it goes above 6G, we really have no choice. FR4 just can't handle it anymore. This is where you see high-end applications like radar, satellite antennas, and so on. At this stage, price is no longer the main factor to consider. A lot of people ask, do you have to use a 6-layer board for RF? Actually, for most products, a 4-layer board is already quite sufficient. As for 2-layer boards, you can use them for RF too, but it really tests the designer's experience because impedance control is much harder with only 2 layers. You're routing traces on one layer, and on the other layer, sometimes it's hard to ensure the integrity of the ground plane. A 6-layer board is definitely much more comfortable to work with, but your wallet will feel the pain. It's also very expensive, as you can see. If you're only going to take one screenshot today, make it this one. This is also the reference chart I use most often when recommending board materials to clients. All right, let's take another look. So for frequencies below 1 gigahertz, our first choice is the F24 board, and a 2-layer board can solve most problems. The price is very cheap. When the frequency reaches 100 to 300 megahertz, well, we generally still recommend the F24 board, but at this point, it's a 4-layer board, so the price will be a bit higher. When the frequency increases further to 3 to 6 gigahertz, designers need to take multiple factors into consideration. Should you use F24 or S4? At this stage, a 4-layer board can basically meet the requirements, but since the material changes, the price goes up even more. When the frequency is above 6 gigahertz, there's really nothing to consider. You definitely have to upgrade, and also, the board will need to have 6 layers or more, and at this point, the price increases dramatically. After talking so much about board layers, let's take a look at how to set up the layers. In the software, click on Board Setup and select Physical Layers. You can see it here. In this board layer setup, you can choose the number of layers, anywhere from 2 to 32, all in multiples of 2. Then, below that, this is what we call 2 identical layers, with the default FR4 material and copper thickness in between, as well as the thickness of the material and the time constant. When we open CAD for the first time, if we're designing RF, we can't just start drawing lines right away. The first thing we need to do is define the board layers, because impedance is determined by the stackup. It's the same in ideal as well. Let's take a look. You also start by selecting the Stackup Manager, and then you can see that it also, here you add the number of layers, then select the material, set the thickness, and so on. Basically, all these EDA software programs have a layer manager to handle this task. A lot of beginners spend a lot of time studying routing, vias, and matching, but often forget the most fundamental thing, which is the stack up. If the stack up is wrong, everything after that is just trying to fix mistakes, especially in RF. The first step in RF design isn't drawing traces, it's deciding what your board will actually look like, what kind of stack up structure you'll use, and what materials you'll choose. Thanks for watching.